Hey guys, Mr. Gran here. Transformations 9.3. So we'll cover this over a couple of days. The first day we're going to take one batch of types of transformations, and then the second day a different one. So what I mean when I'm talking about transformations is transforming a graph. So what happens mathematically when you take a parabola and you want to move it up, or you want to take that parabola and move it to the side, or you want to stretch it horizontally or compress it or flip it over so it's upside down, that sort of thing. All right, so we can express them several ways. One of them is a verbal description. So things like shifting up 1, down 5, vertical stretch of 8, stuff like that. Function notation, we'll talk about this a little bit. We're not going to focus on this a ton because of the time constraints with everything. And then the equation. So how does an equation of a parabola change when it goes from the regular parabola, y equals x squared, to now one that's been shifted up 5? How does that look different? And really the point to all of this is to really give you guys a foundation that we can build on when we start examining families of certain types of functions, polynomials, rational and radical functions, that sort of thing, where we're going to start to really look at what happens to those specific functions, how you stretch and manipulate them and things like that. All right, so this is a lot of information. We are going to cover all of this, not all of it in one video though. So if you don't want to just copy all this down, I understand that. We're really going to live in this section and this video, and then cover the other two in the next video. So it'll break it up a little bit. All right, so one thing with these transformations. What we really want to look at is what's happening inside of the grouping symbol or the parentheses and what's happening outside of the grouping symbol or parentheses. So if we talk about f of x, right? F of x is inside. The input is inside the parentheses. If a transformation happens outside of the parentheses, like we're adding a number out here or we're multiplying by a number right here, this is a vertical transformation. And this does what you would expect it to do, meaning a +2 is going to move it up 2, not down 2. Multiplying by 4 is going to stretch it by a factor of 4. It's going to make it get bigger. It's going to get taller. If that transformation happens inside the parentheses, however, so if it's like f of, maybe we've got 4x plus 2 on the inside, now we've got horizontal transformations, and actually we won't do two of them at the same time. If it's on the inside of the parentheses, it's horizontal, and it actually does the opposite of what you would expect it to do. So that +2, you might think horizontally plus is this way on a graph, but actually it moves it to the left of the graph instead. All right, so let's take a little look at Desmos sliders and just see what happens as we start to manipulate some of this stuff. All right, so if you can see this equation, there's a lot going on there, but I'm going to just look at one little piece at a time. One of the things here is we've got a plus d on the outside. So essentially we are doing x squared plus a number. It's outside of the parentheses, so it should be vertical. What happens when I start changing that number, if I make that number bigger, the equation moves up, and as I make that number smaller, the equation moves down. So a vertical shift up or down is created by that adding on the outside of the parentheses. Now if I change this over and I focus on this number that's being added on the inside, so if we do x plus c squared, and if I use this slider to manipulate that, as I make that number bigger, as I add a number to that, make it positive, it moves to the left. And as I change it to negative, so minus a number, it moves to the right. So it's the opposite of what you would think. And the other one we're going to do today is a vertical stretch. So now if I have a times x squared. So what happens there, as I make that number bigger, the parabola gets skinnier because it's getting stretched vertically. And as I make it smaller, but still positive, it gets wider because it compresses vertically. So hopefully that helps, get a visual with some of the things that we're are going to be doing, because most of what we're actually going to be asking you to do is it's really abstract, just working with the equations more than anything at this point. So so translations, this means shifts, right? A translation is a shift. Everything stays the same size, it just all moves together, left, right, up, or down. If we've got a number on the inside, if we are subtracting a number, it is a translation to the right, or a shift to the right. If we are adding a number, or subtracting a negative number, you will have a translation to the left. You're shifting to the left. A vertical translation would be if it's on the outside. If you're adding that number on the outside, it's moving up. If you're subtracting a number on the outside, it is moving down. Knowing how to tell the difference, one thing that can help, horizontal homies and vertical visitors. If something is inside the home of the function, inside the parentheses make the home, or the grouping symbol makes the home, that affects the horizontal part of the function, so it is a horizontal homie. If it's outside the home, it's visiting. It is a visitor, it's a vertical visitor. All right, and then with vertical stretches and compressions, again, if we're multiplying on the outside, a number greater than 1, if you multiply by a number bigger than 1, you grow, right? It gets bigger, so it stretches. If that number is less than 1, however, it compresses. And we could even add in here, if we want to be really correct about this, greater than 0. So numbers like positive 1/2, positive 1/4, positive 0.8, stuff like that. Okay. So now some examples. We're going to ask you to describe the transformations of functions. So we're going from this parent function, the original one, x squared, to these equations. How does adding this 2 right here affect this graph? How does it change it? That's what we're asking you to describe. So adding 2, it's outside. There's no parentheses, so this is a vertical visitor. That's going to mean it's up 2. This one, another vertical visitor. There's no parentheses. Minus is down, so down 7. Now we've got our first horizontal homie. It's inside of the parentheses. It's a -5 inside. The horizontal homies kind of do the opposite. So a -5 isn't going to move to the left. It's going to move it to the right. Down here, +1 inside the parentheses, another horizontal homie. That is going to move to the left 1. And now some doubles. I've got both. Inside the parenthesis, the horizontal homie part of this is going to move to the left 3, and the vertical visitor part outside the parentheses is down 4. Switch some numbers around here. The minus on the inside is going to move it right 4, and the +3 on the outside is going to move it up 3. Okay. So doing the opposite of that is rewriting the equation given a verbal description. So x squared moving up 5 and left 2. The horizontal homie part, let's make a home here in parentheses. Left 2 would mean we have to add 2. Up 5 would mean on the outside we have to add 5 for the visitor. Down 1 and right 1. So the homie is moving with a -1, and the visitor also a -1 for down 1. Then our last one here, our homie left 8. That's going to be a +8, and down 4 for the visitor on the outside. All right, so stretches. Stretches are kind of nice because there's not a lot to it. We're going from our parent function of square root of x to now 3 times the square root of x. 3 is multiplied on the outside, so that tells me it's a vertical visitor. Vertical stretch of 3. Feel free to abbreviate as much as you see fit, because I'm going to as well. So VS for vertical stretch. Same thing here, vertical stretch of 5. That 5 on the outside means it's going to stretch by a factor of 5. Then we've got some compressions. These are positive numbers, but they are less than 1. So now we'll say VC for vertical compression of 1/2. And then same thing with this one. VC of 1/3. All right, same idea, except backward. Nice part about this is if it's just a vertical stretch or compression, really, for all of these, you can start with that. Stretched vertically by a factor of 5, boom, put a 5 in front of it. That's all there is to it. Compressed vertically by a factor of 1/8, 1/8 times square root of x. Stretched by a factor of 10, 10 times the square root of x. And that's all there is to that. All right, a little combo platter. Now this first one I think is a typo, but I left it in there just because I thought it was kind of a fun one. Left 2 and then right 5, right? So we're moving like, if we start here, we're going 1, 2 to the left, and then 1, 2, 3, 4, 5 to the right, which would end up being a total of 3 to the right is what I think is going to happen, but let's check it out. 2 horizontal homies, so we got to make a bigger home to house all those homies. Left 2 is a +2, right 5 is a -5, and so if we simplify that, it does end up being an x -3, which would tell me that it's moving to the right 3. Now, I promise you there won't be one like that on the test. All right. Stretch vertically by a factor of 4 and down 5, so we've got 2 vertical visitors, so we don't need any parentheses, don't need a home for these guys. 4 is being multiplied for the stretch, -5 to move it down 5. Compressed vertically by a factor of 1/3, so multiplying by 1/3 and then translating up 1, so +1, no parentheses needed. All right, let your teachers know if you have any questions on this. Once you get the hang of it, it's not too bad, but it's new rules, and it's tough when especially if you're a virtual student, where you're not necessarily getting like the full version of everything. We're getting you just the stuff that you absolutely need to survive the next part of the course. So if you need further explanation, let your teacher know, and we'll be happy to get on smaller sessions or discuss it further.